Okay. My voice is audible?
Yes, sir. Yes.
Okay, thank you. So, good afternoon to all. So, we are going to see the remaining part of this unit. So, first of all, I will revise some of the part. So, we have seen types of gearbox, in that sliding mesh, then constant mesh, and constant mesh with synchronizer. That is nothing but the synchromesh gearbox. So this already we have seen. Then next part that we have started, that is nothing but the overdrive. So with respect to overdrive, we have seen how it is constructed and what is overdrive. So it is a device in an automobile which is connected in between gearbox and the propeller shaft to provide an additional speed for the propeller shaft. So with the help of epicyclic gear train, so it is possible to fix one of the element in the epicyclic gear train, which is in the form of sun and planet gear in the overdrive. We can have overdrive by rotating this output shaft more than the speed of this input shaft to this whole assembly. So that is nothing but the overdrive. So in theory of machine, we have seen epicyclic gear train. So just I will take one extra slide to give an idea about how we can rotate output shaft with the speed more than the input shaft. So screen is visible. Somebody can respond. This is sun gear. This one is planet gear. This one is planet gear. And this one is the ring gear. Screen is visible. My voice is audible.
Yes, sir.
Okay. So this is sun and planet gear, epicyclic gear train. So whatever here, this combination that we are going to check. So this sun gear, it is mounted on the input shaft, and this sun gear is in mesh with the planet pinion, or instead of planet pinion, we can call it as a planet pinions. So number of maybe 3, maybe 4, those are mounted on the carrier. So like this arrangement, it is provided. So in the side view, so as we need to see how speed is increased, we need to go in detail with respect to this overdrive. So this one is the one arm, or we can call it as a planet carrier. Okay, so you can now relate this diagram. So here it is input shaft and output shaft is connected to this casing. Okay, and here another arrangement regarding free wheel is provided. So input shaft is connected to the sun gear. Now when this ring gear is going to rotate, so generally while dealing with the numericals with respect to epicyclic gear train, we have seen arm is fixed. So like that, you should consider this one is the arm, and accordingly we have made that table of motion. So, and this we can call it as A gear. So I will write here A, and here it is R. So like this, already we have seen types of numericals. Then here NS upon NP, and here NS upon NA. So like this, first row we can get, and finally we are adding here Y as a rotation for the arm, and we can get Y here, X plus Y. I am writing directly Y. If this is rotating in anti-clockwise, this will rotate in clockwise. So Y minus X NS upon NP, and for this Y minus X NS upon NA. So this is internal meshing. So whatever direction of rotation of this P, the same will be given to this A. Now for one revolution of this sun gear, what will be the revolution of this ring gear? So if for one revolution of this sun gear, this ring gear will have more rotation, then we are going to say that it is having overdrive. That is, the input shaft will have 100 RPM, and if this will rotate with more than 100 RPM, then we can call it as a overdrive. So such principles of superposition is used accordingly as per the requirement. Either casing is keyed or arm can be fixed, and drive there are different modes. So through this we can obtain speed, and that speed we can call it as a overdrive with respect to this input to the output speed. And if overdrive is not engaged, then we can have this direct drive via this free wheel clutch. So here this overdrive can be engaged whenever vehicle will have certain speed, or whenever vehicle is going to reach a constant speed, let us say 80 kilometers per hour, then the transmission can be engaged with the overdrive system or overdrive device. At that time, so power is transmitted through this just by increasing the speed, and whenever speed is not constant, overdrive is not in action, whatever input shaft, it will rotate this free wheel, and again power is given to this output shaft. So like this, overdrive is going to work, and it is provided on the automatic transmission vehicles, wherein we can have the cruise control, or wherein we can have better fuel economy. So this is about one of the device. So this is okay. Then next important component of the automatic transmission system. So generally we have seen there is manual transmission system, and another one is automatic transmission system. So in case of manual transmission system, so once again I will show that summary regarding the manual transmission system and the automatic transmission system. So please wait. Okay. So these are the units of transmission system. So clutch always required. So in the manual there is clutch assembly. In the manual transmission there is clutch assembly. In semi-automatic transmission there is fluid coupling. Again, in the manual transmission there is gearbox. So in automatic transmission there is torque converter, and these are the additional element required for both the transmission. So based on which transmission system is used, one or two elements are going to be varied. Now you can see the image displayed on the screen that is related to the hydraulic torque converter. So previously we have seen fluid coupling. On the similar ground it is also working, but in addition to that, one more element is provided, and that element is called as stator, and which can be used to guide the oil. So you can see this. This is the fluid coupling. So I will put this figure on the same slide so that you will get idea about what is difference between the fluid coupling and the torque converter. My voice is audible? My voice is audible? Somebody should respond.
Yes, sir.
Okay. So this is fluid coupling, And here the another device which is part of automatic transmission, and that is called as a torque converter. That means there is multiplication of torque, and because of multiplication of torque we can have larger torque, and that will fulfill requirement of the transmission system. So this left hand side image, it is related to the fluid coupling. So whatever working of the clutch, the same connection and disconnection device in the form of fluid coupling, wherein there are two parts. One is pump impeller and another one is turbine runner. And this pump impeller is part of the casing. So for the fluid coupling, there are two parts. And here in the middle, you can see one image, and with that image you can check how modification in the fluid coupling are made to make it as a torque converter. So this one is one example. So once fluid strikes, so this cup is shown. After striking, it will impinge in the reverse direction, and that will resist the rotation of the turbine. So again, that will work in opposite direction, or that will work as a resistance to the motion of the turbine. Sorry, motion of the impeller. So in the second image, what modification is made? So there one plate is shown, and with that plate it will act as an obstacle, and because of that whatever fluid impinging and again providing resistance to the impeller, that has been diverted by providing a split. And that element, if such elements are provided on one of the rotor or one of the device, that will guide the fluid, and in addition it will multiply the torque, and the same is used in case of the torque converter. So here you can see the construction. So this is engine shaft. This one is similar to the our turbine, which has been made on the right hand side for this fluid coupling, but here it is on the left side for the torque converter. So once this turbine will rotate, that means that power is transmitted from engine crankshaft to the transmission or rest of the transmission. So aim of the coupling or the clutch or the fluid coupling or the torque converter is to provide connection and disconnection of engine power to the rest of transmission, as well as in addition to that, the torque converter has one more function. It has to multiply the torque to fulfill the requirement of the transmission system. So basically the turbine. So this turbine, it is mounted on the output shaft of this torque converter. Here it is written turbine shaft, and the impeller, pump impeller, it is mounted on the casing which is attached to the engine crankshaft, and this one is the stator. So when this engine crankshaft rotates, so whatever fluid, so inside this pump impeller, so here, so it will impinge like this, and again it is guided through this stator and will have the same direction of the flow. So this stator is the element which guides flow of fluid, and ultimately it will add to the torque, or it will multiply the torque. So in terms, with respect to the increase in the engine speed, the amount of torque is also going to be increased, and that way this third element, that is the stator, is acting as a guiding unit for the flow of fluid, and accordingly the torque multiplication is going to take place in the hydraulic torque converter. So this is an element which is used in automatic transmission system. Here one more figure you can check. So here this is the impeller, this one is the stator element, this is part of impeller, and this one is the turbine. So this is input shaft, this one is output shaft. Aim is to connect this input to this output shaft. How to connect? With the help of the fluid, and which is provided inside this impeller. So because of the flow of fluid, it will rotate this turbine, and after rotation, whatever fluid remaining, again it is guided, and again it is provided to the turbine via this impeller. So like this all the times. So as soon as accelerator works, it will multiply the torque like this, and this will rotate the output shaft. So you can, okay. So function of this stator is to guide the flow, which will help turbine to get more speed. So this is about the torque converter. So in the fluid coupling, there are two components, and in case of the torque converter, there are three components. So additionally, one stator unit is provided, so that will multiply the torque, or simply this torque converter is also called as a torque multiplier. Okay, so another image for your understanding. So here you can see again engine crankshaft. This is converter casing. Inside this is pump body. This one is pump body. This is turbine, and which is connected to the turbine shaft, or we can call it as a transmission input shaft. So instead of gearbox, so gearbox is required to vary the torque as per the requirement. So torque converter, it is also required to vary the torque. So in the automatic transmission, this torque converter is there. So you can see here, whatever way I have told on the previous slide, the same way you can check. This one is the pump. This is direction of oil flow. Again, because of centrifugal force, it will flow in this direction. Again, through this turbine. If the stator element is not provided, then it will try to flow, or it will flow in this direction. So to guide in the direction of flow of this pump, a stator is provided. So you can check this in this image. Okay. And here there is one-way clutch, or in another word, we can call it as a free wheel. So you might have seen there is free wheel for the bicycle. So whenever we are rotating pedal in clockwise direction, then only that bicycle is moving, or in the forward direction. Whenever we are moving or rotating pedal in the anti-clockwise direction, so what you are observing, so the torque is transmitted in the one direction, other direction. So there is no mechanical motion, only that free wheeling is possible. So that's why it is called as a free wheel. So, or sometimes we might have said it as a free wheel in Marathi, but actually that is English word free wheel, and which has motion in one direction to transmit the torque, but another direction it is freely rotating. Okay. Then next component of the automatic transmission system, that is nothing but epicyclic or planetary gearbox. So whatever way we have seen that overdrive, so same thing you can take as an example of epicyclic gear train or gear set. So in the automatic transmission, such sets are provided. So for based on the requirement, how many speed we need to provide for a particular vehicle. So this is one combination. So we can eliminate this part, and this is for one ratio, this is for another ratio, and 3, 4, 5 like this. So this combination, so for one speed, there is combination of sun gear, planet gear, and the ring gear. And what you are observing, this one is the brake pad. So if in the epicyclic gear train, either we need to, for tabulating the data, we are, or casing or the R is fixed. But in actual, as per the requirement of the speed, one of the gear we are fixing. So here to fix ring gear, brake band is required. Again, sun gear can be fixed to the casing, but ring gear can be fixed by providing the brake band. So this brake band is provided to fix the ring gear, and accordingly we can get the speed. So such combinations are provided in the automatic transmission, and that will give the speed, various speeds. Please. So I am sharing another slide. Screen is visible.
Yes, sir.
What is the topic on the slide, Milind?
Propeller shaft.
Okay, good. So this epicyclic or planetary gearbox. So already this part we have covered. The next important component, and that component is called as a propeller shaft. So engine is placed at the front, and the transmission system has to rotate the wheels which are provided on the rear axle. So after the engine, there is clutch that will connect and disconnect power from engine to the transmission system. After the clutch, there is gearbox. After the gearbox, in the automatic transmission or in some of the vehicle, there is overdrive. And after the overdrive, there is propeller shaft. So the propeller shaft is used to provide power from gearbox to the final drive. So just I will draw one schematic diagram here. So this is engine, and here it is wheel, and how to provide So there was issue regarding internet. Milind, am I audible?
Yes, sir. Audible.
1 minute, I will share the screen. Okay, screen is visible.
Yes, sir.
Okay, so we were discussing about propeller shaft. So as power is available at the crankshaft, and with that power, the wheels needs to be rotated, which are mounted on the rear axle. So how to connect that? So for that, a clutch, gearbox, then the propeller shaft and final drive is required. So this one is the propeller shaft. At the one end, there is universal joint, and another end, slip joint and the universal joint. And at the middle, there is body of the propeller shaft. So you can see the animation. So this one is cross, and this is the yoke. Okay, so such component is attached, so you can compare these two. So spider is provided at the middle and two yokes. One is a driven yoke and one is driving yoke. So this one you can call it as a driving, and this one is the driven. Okay. So this propeller shaft along with the universal joint can be used to transmit power having, so whatever inclination with respect to this horizontal is around 30 degree. It should not be more than the 30 degree. So less than 30 degree, it can be used. So more than that, it is not possible to transmit the constant speed. So whatever available speed at the output shaft of the gearbox, so same is not provided to the input of the final drive. So again, for more than that angle, so constant velocity joints are used. So this is again another image. So this is to gearbox. This one is propeller shaft, and this is to rear gear, rear axle gear, or simply the final drive. So here two universal joints. Okay. So this additional figure you can check. So here you can see two propeller shafts. So instead of providing one long propeller shaft, so it can be made with two sections which can be supported with the center bearing. So for vehicle having short length that Bolero, it is having single propeller shaft. Again, for tracks, is having single propeller shaft. And if you are going to take example of trucks which are having two propeller shafts, so again, to have a proper balance, it is made in two parts, and it is supported with the center bearing, which is provided or mounted with the help of the cross members. So these are the long members, and these are the short members for the chassis, and here it is center bearing is provided. So this is about propeller shaft, universal joint and the slip joint. Slip joint used to compensate the increase or decrease in the distance. Then next device, which is the last part of the transmission system. Thereafter, there is no change in the speed, or there is no increase or decrease in the speed, and that's why it is called as a final drive. So this one is to the rear axle gear. That is nothing but this is the propeller shaft. Already it is shown in this diagram as well, and this one is the bevel pinion, and this is the crown wheel. So this combination of pinion and crown wheel, which is used to transmit or to divert power. So already we have seen the flow of power from engine, then to the clutch, then gearbox, then propeller shaft along the length of the vehicle, and that needs to be diverted to provide power to the axle. So how to divert that, or how to transmit power at 90 degrees? So for that, there is bevel gearing or bevel gear arrangement, and one of the arrangement is bevel pinion and the crown wheel. So this assembly of crown wheel and the bevel pinion is known as the final drive. So it is called as final drive because this is the last stage in the transmission system. So whatever speed of the propeller shaft, and as per the number of teeth of bevel pinion and the crown wheel, so there will be final speed for the casing or the crown wheel. Thereafter, that is not decreased or the increased. So that's why this component in the automobile is called as a final drive. So it is last stage of the transmission system. So please wait for a minute. Now just remaining part I will take in the next lecture. So I will take attendance. I want to take attendance. So please wait for 1 minute.